dual recording, one through GoToMeeting, another through a desktop software, so that we do not miss the videos the way which has happened in past, because the video got corrupted because of GoToMeeting. So we do not want to take a chance now. Alright, so the recording has been started on both the places. Let's start the discussion. Okay. So yesterday we started our discussion on Zookeeper, and in Zookeeper, all right. So okay, so those who have missed a bit, so Zookeeper is an independent component. All right, Zookeeper is an independent component, and Zookeeper essentially helps you in coordinating between various tools. All right. So, for example, the HDFS name node uses Zookeeper to talk to data nodes. Similarly, HBase uses Zookeeper in order to coordinate with the region servers. And region servers talk to Zookeeper in order to update their information to HBase as well as coordinating amongst themselves. So, when you have multiple threads, the technique like semaphores or techniques like threads, techniques like threads, they suffice in order to coordinate between multiple threads. Semaphores, monitors, and locks, all of these suffice when you have multiple threads on the same machine. Now, the moment you have multiple machines who require coordination, then you require a third-party service which help these multiple instances to coordinate amongst themselves. Okay. The example we gave was something like there is a service which is running on hundreds of machines. They need a coordination. In those cases, we needed a central service. Also, the other big use case I can tell you. So we were running a service which was basically downloading data for something, and which was also doing some processing in it. Now, so when it was doing processing, it was okay. But when it was downloading data from somewhere, we needed to make sure that multiple instances of same software running parallelly in the cluster should not hit a website at the same time. Okay, if all of the services are hitting the same website at the same time, then that website might go down. Therefore, we needed a coordination system centrally, and this coordination system, as you can see, should be really capable, because this coordination system will be used globally in an organization. This coordination system will be multi-purpose. There'll be all kind of requirement would be there with the coordination system. Therefore, this coordination system itself has to be highly available. So it has to be highly available, it has to be consistent, it has to be uh, it should not be prone to the common problems like race conditions and deadlocks. Okay, so these are the main problems that should avoid, and it should have 100% failover. Okay, and so on. All right. Now, Nitika's question is that what is the role of Zookeeper in case of HBase? Okay. So if you see when we logged in, I will show you a few things. I think this is most important part. So you can imagine that Zookeeper is a central system, central file system, where all of these services come and write their data or delete their data, update their data. So Zookeeper, you can imagine that it's like a central file server on which people keep on writing data, and people keep on figuring out, oh, because the file has been created by this guy, that means he's up. So this kind of model you can think of. Now I'm going to show you something interesting. So, okay, services means any program that runs in the network. Everything is a service in our case. Data node is a service, name node is a service, job tracker is a service, task tracker is a service, and HBase master is a service. Similarly, HBase, say MySQL is also runs as a service. Anything which keeps running and waiting for customers to connect, and it's always ready to serve. Okay, so customer does not have to run the program. Okay, so a service generally listens on a network port, and whenever the user connects, the way you connect to SSH, so SSH daemon is a service. There is a SSH service running in the on our cloud labs, to which your SSH client called putty is connecting to, and the port on which it is running is 22 port. So your putty is connecting to our service running at 22 port, and whatever you are requesting, that service is responding to you. All right, so I hope that is the meaning of services is clear to all of you. So let's have a look at Ambari. At Ambari we have at Ambari I'll show you that uh, okay, so not Ambari, I intended to show you Zookeeper. Alright, the way I can show you the Zookeeper, the best way is, alright, so let me increase the font. Can you see clearly? Alright, so here we are. So so I'm SSHing to our Hadoop one. Okay. So the way you interact with the Zookeeper is somewhat like you interact with the file system. Okay, you see what all nodes are there. The basic difference with respect to the file system is like this, that the model is everything is a Z node or Z node as we call it in India. So everything is a Z node or Z node, and the topmost node is slash, which is by default created in the system the day you start, and then you can create a node below it, and then you can create further nodes below it. So under slash you can create as many nodes as you want, and under each of them you can create as many nodes as you want. Alright, and you can write data other than the name of the node. You can also attach data with each node. You can attach the data at each node. Alright, writing the data on each node is heavily consistent, meaning whatever you write, you will always get, even if you try to read it immediately afterwards. There is no race condition, as in, if two people are trying to write to the same node, they cannot corrupt the data of the Z node. So those are the few properties, and I'll show you a few more things. And why we are discussing about Znode? Because why we are discussing with Zookeeper about Zookeeper? Because Zookeeper is some service which fits into big data, and which basically is just like HDFS. It is also the basic need of all other services. Okay, so you can see. Not here. Oh, sorry, not here. So our Zookeeper is running. So Zookeeper has got 4 Zookeeper clients, and there is a Zookeeper service running. So it's working fine. And here on the command prompt, the way you communicate with Zookeeper is using Zookeeper client. Okay, you can say status here. Uh, Here, not here. All right. So yes. So we can say ls and see what all nodes are there. So there are so many nodes in our Zookeeper. You can see this. These are the various nodes. And interestingly, you will see these nodes HBase unsecure, right? These are the nodes created by our HBase service. And what does it have? Okay, what does it have? Let me see. What does it have? So under HBase unsecure, you have backup masters. These are various other nodes. Okay, and also you can say things like get and the node detail. So on HBase unsecure, there is no other data as of now. So we have meta region servers, backup masters, table, draining, region in translation, running. Okay, let's see what is in the running. So, okay, so we say get. So it says something like the master is running at 60,000 port. Probably that's what it meant. Now, recovering region servers and all right, HBase unsecure, backup master, meta regions, training, running. So, all right. So basically, this is the node called HBase unsecure, using which HBase master is keeping track of how many region servers are available. And as soon as the region server comes up, into this node. It writes into this node saying that these are the region servers running right now. I am up, kind of thing. Okay. So you can see that under RS there are multiple other nodes. Do you see this? Hadoop 4, Hadoop 3, Hadoop 2. So these are the 3 region servers we have configured to run. So the way it is done is we tell HBase master that this is where our Zookeeper is running, and we tell all the region servers that this is where our Zookeeper is running. All right. So HBase master keeps on asking Zookeeper that how many region servers are up. Okay. So instead of maintaining its own registry, maintaining its own list of things, it basically lets Zookeeper keep that list of region servers. Okay, this way you can infinitely scale region servers. If you have one more region server, you tell region server that turn yourself as soon as you get started, please update Zookeeper, and it will update the Zookeeper, and master will get to know that one more Zookeeper has come up. All right. Yes. So you have to run Zookeeper client, Nitika, before this is the Zookeeper command prompt. All right. So type Zookeeper and press tab. You will see client, and then that's the one which we are using right now. Okay. So basically, this is the command Zookeeper client you have to run, and then you can see this. All right. So I hope you got the idea that how is Zookeeper being used for coordination. No? If you want, I can explain again. Correct. Very good question, Vinay. Thank you. So, Vinay's question is, what if Zookeeper dies on a machine? So, Zookeeper itself runs on multiple machines parallelly. Okay. Zookeeper itself runs on multiple machines, and that's a very important aspect. All right. I'll show you how does Zookeeper runs on multiple machines, and that's probably the most important discussion we can have today. All right. Other than the syntax, because the philosophy of the Whisper protocol, we call it Whisper protocol, is what what our Zookeeper depends upon. So Zookeeper is built upon a similar protocol like a Whisper protocol, and we will talk about it. Okay, so it's very different from master and slaves, the way we have studied in case of HBase, in case of our yarn, in case of our the file system HDFS. There were masters and slaves. Here that's not the case. Correct. So Zookeeper does not connect to master as well as region servers. These master connect to Zookeeper. Zookeeper keeps on running. Master comes up, asks how many region servers are up, and Zookeeper replies that these many region servers are up. And region servers tell to Zookeeper that hey, I am up. Please make the note of mine. In case HBase master comes around, tell him that I am available here. This is my IP address. This is the port on which I am running, and please connect to me. When please tell HBase to talk to me. So that's the kind of conversation happens between master, HBase master, HBase region server, and Zookeeper. So if Zookeeper is down, then HBase master and region servers will go down. Okay, there is no point of them running. So region servers will not start. Okay, and in case they have started, they will stay zombie and they will not receive any request. All right, so that is the data model. Then, so this is clear, right? So Zookeeper is just like file system. We have folder, inside folder we have files and so on. Here there is only one thing, a node, Z node. A Z node is a node which can have data, also which can have children, and recursively defined. Standard definition of a tree, correct? And the few important things you should remember is the nodes only provide get and put. The nodes do not provide up delete or sorry, nodes do not provide the facility of appending to a existing data. Okay, you either overwrite the data or you delete the data. Okay, that's the kind of operation it provides you. So only get and put, get, put, and delete. Hi. Why did I start hearing my echo? So everybody on the same page, or is anybody lagging or something? Because here it does not, because we do not depend here on any of the previous knowledge we have acquired so far. This is like the basic course, and this is something on which everybody depends. It does not depend on anybody else. All right. So Abhishek, Amar, Harshal, Minu, Pop, Rania, Sanjay, Sweta, Vikas, Vinay. So, is it, are we all on the same page that what is a zookeeper in general? Okay, zookeeper is a central service which keeps running, to which all the people keep on writing their data, reading their data, and coordinate that way. All right. So generally, when you are setting up a data center, And you know that there are going to be hundreds of developers of various services, and you have other hundreds of services running across the organization. You would like to set up Zookeeper on the day zero itself. Okay, and using Zookeeper, lots of things could be done, and lot of load balancing can be done. So also it also brings to the point that it also brings to the discussion that there has to be a security on each Z node. Okay, we can configure Zookeeper such that we can allow various services on various ports. Okay, also we can also provide a login based authentication. We can also provide LDAP based authentication, so that if I am running a service, I'll be allowed only on particular node, not any other node. Okay, that way one service will not fiddle with other services and will not try to confuse the other services. Now the basics of the Z node. So there are multiple kinds of Z nodes. The Z nodes or G nodes. One is persistent. Persistence means even if you disconnect and reconnect to the Zookeeper, or Zookeeper gets restarted, this node will remain as such. This is the default kind of node. Okay, so you can see here we can simply say create, and then we can create a node. Now there is something called ephemeral node. Ephemeral nodes are something that get deleted as soon as you disconnect. Okay, if you just created a node in this session and you disconnect and try and reconnect again after some time, the ephemeral node will disappear. Okay, so ephemeral node sort of marks your presence in the znode tree structure. So basically there are many utilizations of ephemeral nodes. We will see it later. Ephemeral node cannot have children. All right, ephemeral node cannot have children, and not even if the children is also ephemeral nodes. So because there will always be a confusion that in case this ephemeral node is disappearing, what will happen to all the childrens. So that is why ephemeral nodes do not have children. Okay, although these ephemeral nodes are tied to the client session, meaning as soon as the session disconnects, these ephemeral nodes will disappear. They are visible to everyone. All right. So these are few constructs which help you in various kinds of coordinations. Then we have third kind of a Z node, which is called a sequential node. Sequential node is something whose name is automatically generated. You only provide the prefix, and the next number under a particular node is automatically generated and appended to the prefix you have provided. Alright, so for example, the current running count of /ju is 7. So the moment you say create -s ju and then provide some value, it will get this. Okay, so if the here, since we are trying to create under slash, whatever is the current running count of slash, you will get that. Okay, I'll show you this. So this running count is attached to the node where we are creating it. So for example, here the running count is related to a node called /ju, while here the running count is attached to the slash, and here the running count is attached to the slash. Okay, I'll show you this. So let me just say ls. So for today's session, I am going to create may2, we say slash APR28, and then we put some value. Okay, so we have created this node called APR28. So this is our persistent node. Okay, this is our persistent node. And under this, let's try to create an ephemeral node. We say APR28 and my EPH. Okay, this is the name I'm giving to, and some value. Okay, some value. Okay, now you can see that under APR28, we have created our node. So, okay, when we are saying, right? No, this is not correct. So we have connect, and then we have create minus e path and data. That's right. Oh, I'm so sorry. We are trying to create APRT. It should be APR instead of APRT, right? Because the parent node does not. So we are trying to create my EPH. This is the name of the node under APR28, which we created in the previous attempt. All right. Now the node is created. Now you can see APR28. Under that, this is the node. So if we disconnect now, this node will disappear after few seconds, or maybe after around 2 seconds actually. All right. So if we have to create a sequential node, so we can say create minus s, and let me say that we are trying to create, this is the prefix we are providing, and let me just provide some value to it, because providing value is important. So you can see that the first node that got created below this folder, below this node called APR28, is given 001. Okay, then second node, then third node, then fourth node, and so on, right? Now if you see, if we say ls APR28, you can see that the various nodes are getting created. Correct? All right. Now if we try to create the node under, say, this one, if you try to create a node under this particular node, under the sequence 5 node, we are creating another sequential node. What will be the name? Can somebody tell me what will the name of the node that gets generated? So when we are creating a sequential node, we are only providing one, this path, second, the prefix. So what will be the actual name generated, the way it got generated here? So can somebody tell me what will happen now? What will it say? Will it say, so now in this way, let me ask in more structured way. So will it say created this, Or will it say A is answer this and B is this and 6. Alright. So when we say this, what will happen? Will it say A or will it say B? Awesome. It will say A. Thank you. Great. Yeah. So I press Control C and I'm gonna. So good. So that was the sequential node. All right. So basically, a counter is maintained at every node, keeping in mind that how many sequential nodes have been created, and that incremental counter is what is used to generate these numbers. And where will it be used? There are ample use cases for this. Okay, there are ample number of use cases. You can imagine that when you are running a customer service desk, and this customer service desk is being run parallelly on hundreds of machines, okay, or maybe say 10 machines parallelly, and all of them have to generate a unique running sequence number. In those cases, they can utilize Zookeeper in order to generate a common a common running number. All right. If you remember the ticket numbers, when you are raising a customer support, it generates always a unique running number and so on. For those kind of things, you can utilize the sequential number. Okay. Now, clients keep on getting notification when Znode changes in some way. These are called watches. So clients, whosoever is connecting to Zookeeper, can subscribe to various kinds of events on each node. Okay, and subscription happens during the time of creation of a node or updation of a node and so on. Okay, also these watches are triggered only once if you have used JavaScript before. So it's similar to Java in JavaScript, the way you subscribe to an event. So it's only triggered once. If you want multiple notification, so in the trigger, when it got triggered, you again subscribe. So that's the general model we follow. All right. So what kind of watches are there? So let me explain the commands. So the create command creates a Z node. It can be a sequential node, it can be ephemeral node, or it can be a persistent node. Okay. Also, any node which is created using as a sequential node is also persistent. Okay. Now, delete deletes a Z node, and exists is a command, or ls is a command which checks whether there is a node, and get, there is exist ls and get, there is, sorry, here, so get gets the metadata. Correct. So the topmost node is slash. Under that we have APR 28. Okay. Now if you notice that whatever ephemeral node we created, it has disappeared. Alright. And these are the sequential node we created under that node. So here we have commands like ls and exist, which gets you what is there under the node and also checks whether there is a data, there is this node existing. These are various other commands which you can use. And then there is a command called sync. Sync basically synchronizes client view of Z node with the zookeeper. So when it's making the local modification to get the, you know, to push it to the central zookeeper, it uses the sync. All right. So all these commands, what we you just saw was so for creating, deleting, updating, getting the data, putting the data, all of them can be combined together into batch mode. Okay. If you can combine them together and you can execute all of these into in a batch. Either all of the all members, either all of the commands in a batch are successful or all of them fail. There is no such thing as half of them has happened and half of them uh, has failed. Also, whatever changes these commands are making, they will reflect in entirety. Meaning, they'll nobody will see that the intermediate state. So if we have three commands doing some changes, nobody will see the changes only due to first command, not the other two commands, the intermediate state. So if you have so basically it gives you the atomic kind of a multi update, atomic kind of a batch update. Okay, either everything happens or nothing happens. Also, nobody sees the intermediary state. All see that the result of all the commands in a batch is all the users will see. Either they will see the initial state or the final state. They will not see the intermediary state. Also, all the API of Zookeeper, you can have a look at the various APIs of Zookeeper, and all the APIs are of two kinds, sync as well as async. There are two core APIs, one is in Java, other is in C, and various people have written wrappers over these basic APIs in Perl, Python, REST. Alright? So, okay, so what do you mean by sync? Can anybody explain quickly? Anyone? There are one is sync API and other is async. Asynchronous and synchronous. Yeah? Mm-hmm. Alright. Anybody else? The difference between sync and async. So let me ask you this way. There is a reception desk. Okay? There is a reception desk. You call reception desk to tell them, okay, please inform me if someone comes. Okay. Okay. And the other one mode is you keep going to a reception desk and keep asking, did someone ask for my name? Okay. So these are the two. So you are living in a hotel and there is you're expecting a guest. So you keep going to the reception desk and asking them that, uh, you know, has somebody come for me? Has somebody come asking for my name? So out of this, which one is which one is async? No. So from your perspective, you are again and again B is polling while A is sending a sync request. Okay? All right? The other way or other way would be that there is every day. Okay, so how should I explain this? So whenever you keep checking now and then, every day you go to your post box and you check that if there's a mail that has come in. Instead, if you basically inform them that if there is a mail, just deliver it to my home. Okay? Or if you build a system such that the moment a mail is dropped, you get an SMS, then you are having an async. You are not polling. So one way of checking something continuously and stay yourself updated is by polling, meaning you are going again and again checking something. Other is you prepare a hook such that whenever some event happen, only then you get a notification, right? Correct. Sync is okay. So now let's have a look at from the programming perspective. From the programming perspective, I think this will make it more clear. So if there is a function which makes you wait, that, hey, please wait, let me get you the data. You will have to wait here, okay, to get the data. And if the data is not available or it's taking too much time, then it's synchronous response. Correct. Thank you, Vinay. If you call a function or method and wait for response using function, return value is sync. Great. And async function would have a callback function and you can do your job in parallel without polling. Perfect. So yes, so this description you can see here, you call a method called exists. So this will make you wait until it has given you the response. It will hold your hand and say, please wait, I'm checking in my this, and then once it is done, it will put the response on your hand, and there you go. So basically, sync method is making you wait. Sync method is making your program wait. While async request will say that, okay, you have given me a call, given this call, I will call you back if the node exists. Let me check and give you a call. Okay, it might take me a while to find out whether node exists or not. So please do not wait for me right now. I will give you a call back. So here you will see the difference. It does not return anything here. It is just a void. Second, the argument is same, but there is one, there are two arguments extra. One is the callback. Callback function. Callback function is the one which gets executed once it has found the node or not found the node. Okay, so callback method is the one which will get called, and the context which you have provided, the result will be written into the context method, or while calling back your context method, the exist will give you the data in the argument. All right. So this is one important aspect. Now there is something called watch triggers. Okay. The read operations such as exists, get children, get data may have watches. Okay. So when you are checking for a node to exist, you can also hook there one event that whenever this node changes, inform me. So all of these methods provide you the ways to hook for the events. Okay, watches are triggered by write operations such as create, delete, and set data. Watches are not triggered by read operations such as get data and ls and okay, as well as ACL operation. What is ACL? When, as I told you, that each node also provide you a way to secure it. Access controls. So access control operations such as give the permission to this particular person on this node and and make this node read only. All of these permission related operations do not participate, do not trigger watches, neither they allow you to hook for watches. While watches of exist when you are checking for the node, whether the node exists or not, you can provide a watch that I want to watch this particular node. And those watches will be triggered when the node gets created in case it doesn't exist, or it gets deleted or updated. Similar is the get data and get children. Okay. Now ACLs are something which provide you the access control list, meaning it determines who can participate, who can perform what operation. Okay, access control list is that. Now, what is the difference between authentication and authorization? Anyone? So access control has two parts to it. One is called authentication, other is authorization. Can anybody say answer quickly? Yes, identity is authentication means correct, correct. Thank you, Minu. So authorization and authentication, these two words look very much similar. Authentication is like proving that I am Sandeep Giri. Okay, it's like proving I am Sandeep Giri. That is authentication. And then authorization is saying like I am Sandeep Giri and I was given permission to attend this session. Okay, that is authorization. So for authorization, you need authentication first, because unless you establish the identity, correct, correct. What the permission is I have is authorization. Awesome. Great. All right. So so basically, Zookeeper provides you all that. Reason being, because Zookeeper is going to be used by multiple services, and if somebody makes a mistake or somebody intentionally modifies somebody else's node, then it will become a big mess, right? It will become a big mess, and that is why you should always protect your Zookeeper in order to from these kind of malicious or unintentional or mistaken users. And you can do that by putting an authentication and then putting a permissioning schemes. Okay. Now, basically, there could be three kinds of authentication. One could be on based on IP. One could be based on login password, the normal one. Third could be based on Kerberos. Kerberos is organization wide for single sign-on, so that if you have already logged in into the network, you don't have to provide your login password again. That is for Kerberos. So, all right. Now let's talk about architecture. This is very important, and I would emphasize more on this. So Zookeeper runs in two modes. One is standalone, meaning when you have a single machine, then it will run as a single machine, a single instance. That is only for testing and for learning, but not for real life. Because in case this node goes down, all the services dependent on uh, Zookeeper will go down. Correct? Second mode is replicated. Zookeeper runs as replicated service, and the cluster, basically, it runs as a cluster, meaning there are multiple nodes running Zookeeper simultaneously. And when they are running simultaneously parallelly on multiple nodes, the whole cluster is called ensemble. Okay? Whole cluster is called ensemble. It's for high availability, meaning any node can go down. Still, it will have no impact on the overall system. Okay. Also, it tolerates as long as there is a majority. In the replicated machine, as long as out of three machines, if you have more than 50% machines alive, it will keep running. If you have 50 machines, that means at least it can tolerate the shutdown of 24 machines only. Okay. If out of 50 machines, if 25 machines shuts down, then the cluster will shut down automatically. It will convert itself into read only first, and okay, so I think it will convert itself into read only. It will not shut down. Okay, and Zookeeper is truly highly available. Okay, just like MongoDB, it is also highly available. While our name node is not called highly available if we do not have Zookeeper set up in between. Because in case of a name node is generally singular and all the load goes to the single node, and therefore it's not really highly available. Alright, so the architecture is like this. There are two phases. One is leader selection and other is atomic broadcast. So please recollect when we were talking about name node, data node and all that, it's we who designated a machine to become the leader, become the name node, right? And we also designated other machines to become the data node. Alright? In case of Zookeeper, out of the whole ensemble, out of the whole cluster, one person becomes, one node becomes the leader. Alright, one node becomes the leader, which and all the write requests, whenever you want to write some data, you want to change some values, all those requests will go to the leader, while all the read requests go to the rest of the followers. So there is something called a leader, and the others are called follower. All the write requests, all the requests to change the data go to the leader, while rest of the nodes are utilized for reading the data. Okay. So leader selection happens by all the machines in the ensemble voting for each other. Okay. So they all the nodes will vote for each other based on the ping response they get from all other nodes. And each machine can will also vote for itself, of course. So that's not generally counted. So based on how many votes each individual machine has got, okay, a leader is selected. The leader is the one who is the most responsive one, who is the most fastest one, and accordingly the leader is selected. Okay. So based on the ping response time, when you ping some server, if you have checked on internet connectivity, this that you must have used ping command. So ping is a protocol which most of the systems follow. Similarly, here also there is a heartbeat kind of mechanism where each of these nodes send the heartbeat to each other and then notice that how much time it has taken to get the response from other machines, and accordingly all of these nodes vote for each other, then reconcile, and the one which has got the highest vote automatically is selected as leader. Okay. And in case one leader fails, in case one leader shuts down or fails to respond for some time, the leader is quickly stepped down, or by itself also a leader can step down, and within 200 millisecond re-election happens, re-election for a new leader. So that is very important aspect in almost every big data kind of a solution, because this is exactly how MongoDB and other systems work. Alright. Second, phase number 2 is atomic broadcast. All the write requests are forwarded to the leader. Okay. So first phase was leader selection and other was actual broadcasting. So after accepting the changes from you, the leader will broadcast to all the followers, and it will give you the confirmation that I have written successfully only when majority of the system has accepted your changes. Okay. Okay. Because why majority? Because tomorrow, if we realize there is a conflict, one is saying that uh, I have got this much data, another is saying I have got this much data. Which one should we accept as correct one? So if there are majority, we can reconcile and quickly check. It will automatically check that this is the latest update. So majority persistence makes it possible for a really great consistency levels. Alright. Also, please note that unlike other systems, Zookeeper writes to the disk and then loads into the memory. This makes it possible that your changes are durable. Okay. It means in case machine shut down, the data is there. Everybody okay with this? Any doubts? All right, all right. Okay, this is another way of looking at it. This boundary, the colored one, see the boundary? It represents the ensemble of the zookeeper. There is one leader, there are two followers. If this leader gets shuts down, somebody else will be made leader. And these clients, they keep track of all of these machines automatically. This client library keeps it has inbuilt algorithm to keep a persistent connection to one of these nodes and keep a list of all these machines. All right. Now the leader selection thing, let's have a quick exercise. So if you have three nodes A, B, and C, with A as the leader and A dies as in A is killed, okay, for whatever reason, the machine is burnt, whatever the network plug has been pulled out, or whatever has happened, so A is considered dead. Now, will anybody become leader? Anyone? We talked about as long as majority is voting. In an ensemble, as long as more than 50% node are ready to vote, there will be a leader selection. If the nodes which are ready to vote are less than 50%, there will be no election. Okay? All right. Yes. So who will become the leader? B or C? Why Nitika? Why B? Correct. Both have equal chance. Okay, there'll be election because because leader has been stepped down. Somebody has to become leader so that the data can be written. As I just told you, that there has to be somebody to accept the data. So the election will happen because there are two remaining. Two out of three are alive, which is more than 50%, right? Therefore, the election will happen and either B or C would become the leader. Okay? If two nodes are getting exact equal votes, randomly one of them will be elected as the leader, just like coin toss before the cricket match. Alright? One of them will be decided as a leader. All right. If less than 50%, then 50%, not 5%, no election. And nobody will be the leader. Even if there is a leader, he will step down and there will be no leader in case there are less than or equal to 50% node. All right. Now, in this, B or C will become the leader, as we told. Now, next is C became the leader. A was already dead. C was the leader and B has been shut down. What will happen? Okay, C was the leader. Remember, C was the leader. What will happen? So we had A, B, and C. We came to know that A has shut down. There was an election, and C was selected as the leader. Now what has happened is B has shut down after some time for whatever reasons. Shutdown means unavailable. Okay. So what will happen? Will C remain a leader or will C step down? So there was an ensemble of three computers, A, B, and C. A has already become unavailable. So we elected C as the leader automatically. They themselves elected C as the leader. After some time, B has shut down. So C will continue as a leader or C will step down. No, C will step down from the leadership because C does not have majority supporting it. Okay? she will step down, and I'll tell you exactly the reason, and you will understand why she should immediately step down. There is a very valid reason. So, are you guys with me when I'm talking about this? So, since there is no majority left, because there is only one computer left, it has to step down as per the protocol. Okay. Okay. So, all right. Now, at lot of times we find it strange that imagine that we had 20 computers. Okay, we had 20 computers in ensemble. 10 computers are turned off. Will there be a leader? Yes or no? So out of 20 computers, 10 computers are turned off. Will there be a leader? Answer is no. Okay? Answer is no. And the reason is no majority. As I told you that a leader, there will be election for the leader, or there will be election of the for the leader only if there is majority. There will be a leader only if there is majority. If there is no majority, neither there will be election, and if there is already a leader, the leader will step down. In this case, the moment 10 computers have turned off, if there is a leader, they will step down immediately, and also there will be no majority anymore. Sorry, there will be no election anymore. All right? Don't you find it irritating? You can always say, as Nitika is saying, that, but there are still 10 computers left. There are still 10 computers left. Okay. Majority means more than 50%. Okay? More than 50%. All right? So since not had there been 11 computers, it could have been okay. Okay? But lot of us will say it's a royal waste of our resources. 10 computers are left and still there is no leader. Correct? All these 10 computers are their resources are being wasted. Can anybody give a justice? Anybody give a justification why the leader election, or why does the ensemble behave in this way? Why does this zookeeper behave in this way? Or this is a part of whisper protocol, by the way. So why does this protocol have this kind of behavior? Isn't it a waste of resources that we have already 10 computers left, and we are saying that we cannot have re-election, and we cannot make somebody leader, and hence we cannot accept any write requests? Okay, so the whole zookeeper cluster will become read only. So any ideas, like what could be the reason? Why is the design that way? Anyone? Are you with me on this? This is probably a single thing which took me a while to figure out, and almost everybody knows this part, that as long as there is majority there is election, as long as there is a majority there is election. But most of us, we really don't know why is it that way. Okay, so okay, so Vinay is saying, what if those 10 computers which are turned off, when they come back again, will that be a problem? No, in that case there could be a re-election again. All right. So let's say that for time being, let's assume that we made this design change and made it, no matter what, the election, based on election, we will elect some person, no matter how many nodes are available as of now. Okay? Now let's see what happens in those cases. Imagine this. Okay? Let's say we had two data centers, data center 1 and data center 2. And part of the ensemble is on data center 1 and part of the ensemble is on data center 2. So out of 6 nodes, 3 are on one, 3 are on another. Alright? Okay? 3 are on one node and 3 are on another node. So let us say that there was leader called A, and after some time what had happened was the connectivity between these two data centers has gone down. Okay? So for A only B, for these people there are this node only these three are available. For this network only these three are available. Alright? Now what would happen had there been this no restriction? Okay, had there been no restriction such as that even if less than 50% can constitute, can make the election happen, what would happen now? What would happen? Both of them, both data centers will have their own leader. All right. Now, if you notice that some users are writing to this data center and other users are writing to this leader. Some are writing to A, some are writing to D, which means the the chaos, which means the inconsistency. A client who by mistake was taken to this leader where he wrote the data to A, if it comes to read and it reads from this one or this one or this one, the data will be old. Therefore, there will be a chaos. There will be inconsistency. The users will think that this whole system is stupid and waste of time. Did you get the chance? Get the idea? Imagine that we could have had election even in case of minority. All right. So yeah, if we had election even in case of 50% node, what would happen is both data center 1 and data center 2 will have their own leaders, and which means the changes in A will never reach to change in D, and changes in D will never reach to these nodes, and hence the data will be totally in a kind of inconsistent. All right. That is why we should have more than 50% of majority, more than 50%. Okay? M- that's exactly the reason. Which means there could be only single group of more than 50%. in any set of people. All right? In any set of people, there could be only single group which is more than 50%. Therefore, there could be only one leader no matter how these nodes are connected. Okay? So in order to have a single leader, majority is majority is required. If majority is not required, everybody will have their own leaders, and therefore there will be utter chaos. There will be multiple leaders accepting multiple kind of changes to the same node, to the different nodes, and there will be complete inconsistency in the data. Is everyone with me? Vinay? Good, good. Vikas, Sanjay, Tarak. So everybody, is this idea clear? Why do we need a majority? Because in a group of nodes, there could be only one such group which has more than 50% people. There cannot be two different groups part of a particular gathering having more than 50%. All right? Because that's the definition of more than 50%. And therefore, there will be only a single leader. What is Paxos? I've not used Paxos, but I can give it a shot. Okay, so Paxos is a leader election algorithm. Mm, yeah. So no, it's based on the same Whisper protocol, it's a part of the same Whisper protocol, then it would have the same restriction. Okay. The same mechanism is there in case of MongoDB, in case of other systems which rely on leader election, all of them have exact same phenomena. All right. I can demonstrate to you that in case of a cluster, I'll shut down one by one, and after some time, leader will automatically step down. All right. The moment you reach down lesser than 50%. So an ensemble of 10 nodes can tolerate a shutdown of how many nodes? Quickly. Correct, correct. Great. So yes, it can tolerate a shutdown of 4 nodes. The moment you shut down 5 nodes, the leader will step down. All right. These are the various guarantees which our Zookeeper provides. First is the sequential consistency. Updates from any particular client are always applied in an order. Okay. So here the most important part is updates from any particular client. Okay. It will not mean that when a client is updating, the other client will be put on hold. Unless this client is updating as a batch update. Okay. Otherwise, it will have the updates will be applied sequentially. And atomicity, updates either succeed or fail. Then single system image. A client will see the same view of the system. The new server will not accept the connection until it has caught up. Okay. Durability. Once the update is successful, it will persist. It will not, will be undone. Timeliness. Rather than allowing a client to see very stale data, a server will choose to shut down. Okay. If a zookeeper is not able to contact other leaders for quite some time, the zookeeper client will basically shut down rather than providing the updates to all the users. Okay. And that's probably mostly the reason why our zookeeper cluster shuts down after few days. If there are nobody using it, automatically the cluster shuts down. Reason being, reason being that it thinks that since I have not got any update for full whole day, it does not make sense. Maybe I'm not connected. Although there are heartbeats running around, but still for some reason it is shutting down. All right. Now there is an idea called sessions. A client has a list of servers, so the client library has list of servers in the ensemble. Okay, it tries it until it exhausts the list. It keeps on trying. Okay, it starts from the first server, second, then tries second up till the last server until either it's successful or the list is exhausted. So whenever a client is connected, the server creates a session on the server side as well, and on the client side also maintains a session. Each session on the server side has got a timeout. If the user has got disconnected, the session will be discontinued. Session will be timed out. Okay. So if server does not receive a request for some time, if the server is not receiving the request for some time, the the session will be timed out and session will be deleted, and all the ephemeral nodes will be removed. Okay. So therefore, each client has been designed in a way that it keeps sending the pings. After the connection is successful, it keeps on sending the heartbeat to the server saying, I am up, I am awake, do not expire my session. Alright? Client library, it's not you as a developer have to keep on sending heartbeat in your program, but it's the library provided, uh, the client library provided by Zookeeper that takes care of these internal integrities of the protocol. Generally, this failover is automatically handled by the client library, but your program cannot stay agnostic to the failovers, because while the say it was connected to one node for reading the data, and after some time this connection expired and it is trying to connect to any other node in the meantime. At the same time, your program also started writing the data. So at that point of time when this reconnection is happening, your updates will fail. Therefore, even though client libraries takes care of this reconnection, still you as a developer cannot stay agnostic to writing the data. Okay? And sessions are still valid if your client library is connected to any other node. All right? Now, the our use cases of the zookeeper. So on the right hand side, you see there are so many clients who wants to talk to your servers. There are millions of clients. Okay. On the left hand side, there are hundreds of servers which want to provide the service. Now they want to coordinate with each other, meaning we cannot tell these developers who have developed this client on this side, on the right hand side, to basically keep on trying all the servers, okay, and so on, because some of the servers might be down. So which one should these client connect to is very important part. Okay, this is a typical problem in case of a load balancing. Okay, in load balancing, if the servers keep on frequently going offline, and to manage the load effectively, your client request should not be sent to a node which is shut down, right? Therefore, you need to keep track of which machines are up, which machines are down. Okay, and this kind of requirement is very well catered by Zookeeper. Okay, this kind of requirement is really very well taken care of by Zookeeper. So all these servers, when they come up, they basically inform Zookeeper saying I am up. Okay, and they basically creates a node with their IP address as the data in that node. They create that the nodes for their name. They write their name over there in the Zookeeper. And when the client comes in, they look at the list of available server. They just pick any and start accessing it. All right. So this is one use case. So this is how it happens. So there is this server on the left hand side. Okay. Server is sending a request to Zookeeper. Okay. So if you notice that server is also behaving like a client for the Zookeeper. Okay, because everybody is a client for the Zookeeper. So server is sending a connect request to the Zookeeper, and after Zookeeper has finally succeeded in connection, then it gives a call back to the server saying yes, you are connected and here is your session ID. Okay, now this server says that please create an ephemeral node called duck. Now another server comes online in the similar fashion. It says under the server's node, create my name also please. So that it's like marking your attendance, and these both nodes are ephemeral. Okay, so at this point when duck and cow both are ephemeral nodes, both are available under server's node, at this point if the client is coming for a list of server, he gets duck and cow. Alright, if it says ls/servers. Now after some time, duck the server called duck got shut down or got offline. So it's after a timeout period, its session will be deleted and ephemeral node will be removed. Okay, therefore this duck node will be removed after the server has been killed, and when this user comes in after 5 seconds, it will only get cow. It will not get duck because duck is offline now. Alright, so this is the use case of, in case of a load balancing, how does it keep track of alive and offline servers. Alright, this we have already created, already tested it for you. Okay, we created the node, we also got the data, we can also set the data. Okay, so please, all of these things you should try by yourself as well. Here whatever we have discussed, you should try this out. Okay, so there are many use cases other than this: building a reliable configuration service and a distributed locking service. You can create a locking service based on this. Okay, And using a system like Zookeeper, you can really build a heavily consistent service. Okay, so that's pretty much about Zookeeper. So let's take a break for 10 minutes and come back and have a QA session on Zookeeper and then move on. All right. All right, so I'm back now. Okay. Yes, Nitika, I have received your email. I'll respond after some time. Okay. Maybe tomorrow I'll respond. All right, great. Let's. Do you have any questions on Zookeeper? It's not the most detailed course on Zookeeper, but it is good enough and sufficient enough for you to get started with Zookeeper. All right. Any questions for me? All right. All right. So no questions, Abhishek, Amar. Should we carry on the discussion further? Is my sound sufficiently uh, okay? Yep. All right. So no questions, Vinay, Tarak, and Sanjay, Rania, Pop, Nitika, Menu, Amar. Everybody okay with the Zookeeper? You should definitely do whatever we have discussed in the last session, all of these things, and try out each and every part of it. All right. So no questions. So let's start with another session. All right. So all right. Now let's talk about something called scoop. Okay. So in the beginning of our session, when we were talking about various components in the Hadoop ecosystem, we talked about scoop. That scoop is a tool which help you move the data back and forth a structured source, meaning a relational database, into HDFS or into our HBase, and from HBase back to the MySQL or other database, and so on. Okay. So Scoop is a tool which help you extract data from structured data source into Hadoop for further processing, and can also move data from database to HBase. Okay. And you can export data back to the data store using Scoop again, and it has got many really useful utilities to help you improve your overall performance. All right, and it provides you a great set of extension framework called connectors, and by default Scoop is compatible with any system which provides JDBC driver. And JDBC is a standard, and probably probably there is probably the there is a JDBC driver existing for almost every database. Okay, so so there is no full form of scoop. Scoop is like a scoop of an ice cream. So in that manner, right? So okay, so all of you might be thinking that why do we require a new kind of tool? Why do we require a new kind of tool to extract data from MySQL to our database? Why couldn't we just do it by ourselves, right? Why couldn't we just utilize our Java program and write it to the HDFS? What is so big deal about this? So whenever the big data comes into play, you would notice that the data is humongously high, and therefore first you have to take care of the scale, as in, can we utilize multiple computers to read the data from the machine? Can we do it parallelly? Or the other aspect which is important is, what if something fails in between? What happens in those cases? So those kind of issues are well taken care of by Scoop, and Scoop takes care of all those kind of complexities. So by default, you can log into, say, Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, anywhere. The Scoop is just a client. It is just client library which takes these commands from you. You can basically see, you can connect to any of the nodes. Right now, since I'm already connected, I'll just say scoop. So scoop help. Alright. These are the various commands available. CodeGen means it generates code to interact with the database records. Okay. The most important part is import. Import is always, whenever we say import or export, we always say it from the reference of big data, meaning HDFS. So we import means importing into HDFS. Export means export means exporting from HDFS. All right. So list of available databases you can see from this, and most important part here will be export and import. And yeah, so there are already available connectors for anything that supports JDBC. So you generally don't have to write or try to implement SQL connector per se. Even in the worst case scenario where there is no JDBC connector, you can write a scoop connector, and that should also work. Okay, with this scoop command. So let's try to do something. Here what we are trying to do is create a dummy database from which we will import and export the data from this dummy database, and then we will copy the data from MySQL. Alright, so let's go to MySQL. Alright, so yeah, MySQL user root. Alright, now we already have this scoop ex3. So show databases. So this is my SQL command prompt. I'm interacting with my SQL database, and I'm trying to prepare a demo so that I can show you that how to import data from MySQL into our HDFS. Okay, so let's drop the existing database which we are trying to do and recreate it. Okay, now there are a few things you should note here. First, we are creating a database. All right, then we are giving privileges to Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4. Okay, we are giving privileges to Hadoop 1 and Hadoop all the nodes. Why? Because when the scoop runs, scoop export, scoop import commands, what does it do? It generates MapReduce code which runs parallelly on all of the nodes, and these all of the nodes connect back to this MySQL server and will read the data parallelly from MySQL server. All right, that is why we have to provide the access to all the nodes. And this is one thing you would be mistaken badly when you try to run a scoop command. You would be wondering all the time that why are your jobs failing? Okay, because whenever you are connecting to MySQL, it's working perfectly fine, but why still your job is failing? Okay, and the reason is that if you can access your MySQL database from all the nodes, only then your job will succeed every time. Otherwise, what will happen is sometimes your job will succeed and sometimes it will fail. And you will be cursing Hadoop all the time that how come sometimes it runs, sometimes it doesn't. Reason being, sometimes it might be executing your job on the same machine on which MySQL is installed, and therefore it would be working fine. So make sure that you give the permission to all the nodes such that those all the nodes in the cluster can access MySQL. All right, this is more important. All right, so let's just create some dummy table in MySQL. We are creating a table called widget with these columns. Okay, and here we go. And let's select a database called sgiri here. So what was oh, we just created the database, right? We just created the database. So we say use scoop example 3, and then we create the table. So a table has been created. Now let's insert the data into this. It has got 3 rows. Okay, so you can see select star from widgets. You can see this. So we have created the data in MySQL. Now let's try to import it. Alright? Now let's try to import it. So here we say scoop import, and then we provide the name of the node, okay? The JDBC node. Yeah. Yes, Nitika. And we provide the login password. Okay. So yeah. So we have said yeah, in auto increment you can see that it's a primary key and it's auto increment. So it's it is automatically being generated. Correct? So we can say import, and we are saying that this is my JDBC URL. We are saying Hadoop 1 scoop ex3 is our database, and our connectivity is through JDBC and uh, using MySQL. And then we are specifying our table name called widgets, and then we are saying use only one mapper. Okay, please note this point that we are specifically saying use only one mapper, because if you look at it, our the map reduce job which it will create, there is no file on which it can operate. So the number of mappers cannot be decided by itself because it has no data at all, right? So the number of mappers should be decided based on our choice, okay? Based on how many connections parallelly our MySQL server handle, because most of these databases are really high end. They have multi cores and they have multiple processors, multiple hard disks, and there are multiple ways in which. That's why it is okay sometimes to have multiple machines calling a MySQL server parallelly. All right. Therefore, you can have multiple mappers. So you will have to specify your mapper by yourself here. Okay. Here we are providing the username and password for the MySQL, and this will basically import the data into HDFS into our home folder. So sorry, this has to be executed is outside from here. This will be executed from the command prompt. All right. So this will be executed from the command prompt. Now it has started connecting to that particular database and reading the data from there, and also it has created a jar which basically represents the map reduce. You can see this here, widgets.jar. Alright, so it has written everything here. Successfully imported the data. Alright, now you can see this. It will basically create a widget file in your home folder. Okay, because you have not specified the output location. Now, so let's have a look at Hadoop fs minus ls. Okay, and we say widgets. So it has created a widget folder under which there are multiple mappers. If you had and you see am here, every time we see there is an R here, not M. Why? Because there is no reducer here, and this file is being generated directly by mappers. So it created multiple mappers. Each of these mappers are connecting back to MySQL, reading the data, and writing to it. Just that in our case, the example which we have run, we have explicitly said that there has to be only a single mapper. Let's try this. I've never tried multiple mappers here. Let's try multiple mappers. But since there are only 3 records, I'm not sure if second there will be any data on the second node. I'm just hoping that it should not fail because the directory already exists. Hadoop fs minus rmr, I say widgets. Alright, so it's trying to do something. By default, it looks for a table. In this table, it looks for a column with the name ID. In case your ID column is different, you can specify that other column. Okay. So now let's have a look at what it has done. I'm just hoping that it has created multiple files, but I doubt, because there are, oh nice. So how many mappers did we give? Oh, we said two mappers. It has created three files. So maybe 0, 1, 2 is what it has done. Hadoop fs minus ls widgets. You can see that. And it has basically Hadoop fs minus cat, and we can say so one row in one, second row in second, and third row here. Alright, so it has created multiple mappers, and I don't know why it has created three. Ideally it should have created only two. Never mind. So but it has created multiple when we have mentioned it. It should again give an error. Yeah. Alright. So let's try to import again and keep it only one mapper this time and create a single file. Alright. This way we have imported our SQL table into HDFS. Alright. Also notice that there'll be in this folder there'll be a file called widget.java created, using which we can basically automate the process of importing data. Okay, you should have a look at the widget.java that gets created as a result of this process. Okay, now we are done, and let's have a look at widgets.java. So you can see that it has basically created all of this for us. Okay, it created a class called widget containing a field called id with its get set, and it has also created all of these methods which are required for data in and out. Okay, if you remember, whenever we had to read and write data from one location to another, we generally create these objects in which we fill the data and then carry it over the wire, and this is that object which it has automatically generated for you, okay, based on this table, so that you don't have to type it next time. And also the whole assembly of reading and writing data has been done properly. Okay, it has been done properly inside this. So you can utilize this widget class to do a lot of work. Okay, yeah, it has automatically generated those what do you call these classes? I forgot the name. You call these classes as the object, what do you call, ORM mappings. So alright, now next is that you might want to import the data into Hive. If you remember, in Hive also there are tables. In that you can directly import the data from MySQL to Hive, because you will have to create these tables again in Hive. Instead of that, you could basically import directly from normal database to Hive. Alright, and you can do it this way. Alright, there are two ways. First, there are two ways. One is in three steps, other is in single step. Three step as in, first import the data from MySQL to HDFS. Second, create the table in Hive. Third, load the data from HDFS into Hive. All right. So here we are creating this table in Hive. So so in Hive we will create this table, and then we will, you know, try to load this data. Sorry, the better way is to, okay, yeah, use scoop. I'm trying to use scoop to basically create the table in Hive directly based on your table in SQL, so that you don't have to create. Okay, it has created for you. All right, it has created the table in Hive for you. Now you can go into Hive and say import widgets into widgets. Okay, and remember that when we say load an HDFS location, we are not saying local. Had we said local, it would try to search for widgets file in the local folder. Now we have this will look into HDFS, so we can say load. So data got loaded from this location into widgets table. All right, or you could do few more things. Okay, all right. So in the first step, we loaded the data from MySQL into HDFS, correct? Second step, this second step created a Hive table. You remember we created Hive table. The second step is creating a Hive table and putting it into Hive. Okay, it's creating a Hive table based on our MySQL table. All right. The third step is we are loading this data from the HDFS file folder which was created in step number 1 into a table called widgets in Hive. Okay. So we have already loaded. So we can see that select star from widgets. Okay. It's loaded already. Or we can say drop table. But if we drop this table, the underlying file will be deleted. No, step 1 is not there, step 1 is here. Okay, we imported the data from SQL, MySQL to HDFS. That is step number 1. And step number 2 is this, where we are creating a table. And step number 3 is loading the data into the table. Alright? Now we could do all of this in a single shot. We could do all of this in a single shot. Let's drop this table, drop table widgets. Okay, and go back to the command prompt and say scoop import connect to this SQL and widget name this, and I'm saying minus minus Hive import. Here we said create Hive table instead of saying import, and earlier we said import and we did not say anything else. Okay, now we are saying import followed by Hive import, which means it will also import it into Hive. Okay, here we go. So remember that we have deleted our widgets table, and the output folder has not been deleted, so we can say Hadoop fs minus rmr and widgets. Okay, how come this folder was not deleted? I think we have not deleted our table from Hive. select star from widgets. Widgets is not found. Okay. So Nitika, which one is not clear? Are these first steps are clear? We imported the data into HDFS. Okay. Then we imported the data. We created a table, and then we loaded the imported data in step number 1 into the table created in step number 2. Correct? Now, in single step, we are trying to do the same thing. Okay? In the single step, we are trying to do the same thing. Okay? It will import. Yeah, the database is created already. The database we had already created with the sample data and with the table inside it, and inside table we have populated 3 records in it, right? It's the same table we are using here. So we created MySQL table. First we created MySQL database, then we created a table, then we imported data into it. Now with that table exists for us. Now we are trying to import that table into Hive. So here we imported that table into HDFS. Here in the first part, we tried to import it. We tried to do it modularly, as in we've created a table, then imported data from HDFS to this table. Now what we are trying to do is we are trying to import this table directly into Hive instead of multiple steps. Alright? Using this. So this has now imported the data. Alright? Select star from, what is the table name? Quickly. Widgets. Correct? So the table has been imported, right? We had deleted the table last time. Perfect. All right. Now next is, this is okay. All right. So now we are trying to import the data into, now we are trying to import the data into HBase. Okay. So let me ask you few questions. While defining HBase table, which of the following are required? Number A, name of the column. Number B, at least one column family. Okay. Number C, foreign key constraints. So which of the following are required while we are defining an SQL table? Sorry, HBase table, not SQL table. When we are defining an HBase table, which of the three are required? Correct. We need to provide at least one column family. Correct? And of course, we don't need to define name of the columns while defining a table in HBase. All right, Abhishek and Sweta. So we don't need to define the columns while defining a table. Looks like you have not tried by yourself. So please try the hands-on exercise given in case of HBase in the last slide. Go through each step and try to do that by yourself. All right. So here we are, and Okay, and had there been one more D, name of column, name of HBase table. So will D be required? Yeah, correct, correct. So therefore, when we are forming this SQL query, sorry, scoop command, it says that scoop import the data, scoop import the data from this URL and this table in this particular URL. I mean the connection string basically. We need to also tell the HBase table name, whatever table name you want to create. You can say widgets here. Also, you notice that we have to provide a column family name. Okay? By default, all the columns of this column family will be imported into all the columns of this table will be imported into this column family. Okay? And here we are saying these are the columns A1, comma B1. All right? So we can create a table like this, and we are also saying that our HBase row key is the ID column. Okay, because if you remember, while inserting the data, we need to provide row key, correct? And therefore we need to tell that which column will become the row key. Okay, so we are providing that as ID. Okay, so let's try to run this command and see what happens. In the meantime, let me also open another, or let me open on another machine. Okay, what was that sparking? Alright, what does it say? Okay, it's trying to do something. It looks really crazy. Yeah, this time it's working. Why did it not run in the first place? Yeah, because of the weird dresses. So, okay. So it has created an HBase table. You can see that. And let's open HBase shell here. So you can say scan, and we can provide the name of the table, which was customers. So okay, this is customer, not customers. You can see that. So it has imported all our columns into the same column family. Column family 1, design comment is this, design date is this, price is this, and so on. Okay, and the IDs have become our row key. You can see that. For the ID called row, these are the columns. The, and for the ID equals 2, these are the columns. And for ID equals 3, these are the columns. Okay, the column name is CF design comment, CF design rate, CF price, and CF version, and widget name. Alright, everybody okay with this? So we have successfully imported data from our MySQL to our HBase. Yeah, great. Now next is that whatever we did just now, that we imported data from MySQL to Hive, we could do the similar thing from Hive to MySQL. So let's load the data. Let's create a sample data in Hive. Let's see if it is already created. Okay, let's let us also launch Hive first, and then see if a sales table already is there. Then we don't have to repeat the process. Okay, but you can, when you are testing your things, you can basically try it out. Okay, we can see show tables. So do you see select star from sales? Yeah, we already have this data, this sample data already created. Now all we need to do is we need to create a similar table on the MySQL side. Okay, here the it does not it does not create it does not create the table on MySQL yet. Let's say drop table sales. Okay, we have created the table, and now we are going to run. We are going to, let me also create one more session. Okay, so we are saying that export our table called sales into this particular database. Okay, this is Hive, this is our MySQL, and we are waiting for the data to be populated in this. So select star from sales. Data has come now. Earlier it wasn't there. So the data has been imported successfully from our Hive to MySQL. Alright, any doubts here? Okay, so that was how we import data from Scoop to various places. So we essentially, we basically, what all we did? Okay, there is MySQL, and on the other hand we have HDFS, and we have Hive, we have HBase. Okay, So we demonstrated to you that how to take data from HDFS to MySQL to HDFS, and okay, we also demonstrated to how do you take the data back from Hive to MySQL. These other procedures you can try to repeat by yourself from HDFS. So this one we have not, this we have not done, this we have not done. Okay, you can try by yourself. That should not be much of an issue. Okay, all right. Okay, so now the next one is Flume. Flume, although we all call it like it can copy the data for in the structured fashion, but there are few limitations. Okay, so for structured data, meaning for relational databases, our Scoop was really brilliant. Scoop also provides you far more complex imports, such as only import partial data from a table, or keep on importing this table regularly. Okay, those kind of tasks Scoop can do pretty well. But in case you have to import data which is unstructured, specifically the data like binary data or data like Apache logs, then your Flume comes into play. Flume is really powerful. Now, what is it that Flume provides you that you cannot build? Flume provides you a way to import the data from various kinds of resources into various kinds of target. Alright? So, for example, you have to import the web server logs into your HDFS. For that kind of requirement, Flume is really powerful. It's distributed, meaning it's built for big data. It's heavily reliable and highly available system. Okay, and it basically very efficient for collecting and aggregating and moving large sets of data from many different sources to a centralized data store. Okay, so this is probably the best definition about it. So Flume basically supports the import from various data such as tail, syslog, log4j. Yeah, it is like an ETL tool. Okay, so if you are generating a data at a really fast pace, Flume will be your friend. As in, Flume really helps you import data from very fast paced resources into HDFS. Okay. What does tail minus f do? Anybody? What does tail minus f do? Have you used tail minus f and then a file? Okay. So correct. Thank you, Sweta. Yes. So it basically tail prints last line. In that sense, Nitika and Minu is correct. But tail minus f, and you have some file. Okay. So sometimes what happens is you want to watch a file, you want to see what is being appended to a file. In those cases, what you do is you leave tail minus f and then file name. The moment that file gets created, or the moment we add more records into that file, those records keep on getting printed onto your screen all the time. And tail minus f is really powerful when you want to watch the logs and But if you have a millions of records per day, then tail and these solutions really don't work. Okay. And this is for continuous printing. Okay. As and when the data is being appended to this file, you will see it on the screen. If you if you leave it like this, if you don't have minus file option, it'll just print last 10 records in this file and then exit. Okay. This does not exit. So that means tail minus phi f becomes a valid input source for Flume. And remember that Flume basically takes a continuous input. It is not for a single time use. Okay. You basically set up the Flume, the whole pipeline, and it'll keep on reading the data from one end and keep on pushing that into HDFS. Okay. HDFS is just one example. Also, few things like other than tail, you can use syslog. If you know syslog is standard way of Unix to generate to run a log daemon which receives logs from all the services in the system. Okay, so Flume has inbuilt support for syslog, tail, and log4j. Okay, also Flume nodes can be arranged in an arbitrary topologies. What does it mean? It means that one node can become the source of uh, of data for another node, and another node can become the recipient for another node. Okay, let me go back to this diagram. So you have this web server, which is the source for your Flume. And so, okay, so I think a better thing would be to explain again. All right. So, so that was the utility of Flume. Where do you use it? Okay. Now let's understand the little bit of architecture. So, Flume is a bunch of agents. Flume comprises of bunch of agents running on multiple machines. All right. So one agent running on one, another agent running on another, and so on. Each agent is composed of three things. First, each agent knows the source of data. There is a source of data. Second is the sink, meaning where the data needs to be written. Source of data means Flume, the agent will read the data from source, write it to the sink. Okay? And in the meantime, to bridge the gap between reading writing speed of sink and source, there is a channel. Okay? Parallelly, from on one hand it will keep on reading from source, on other hand it will keep on writing to the sink, and in the meantime it will keep it in the channel. Okay, so if the sink is really fast in writing, then channel will always be empty. In case source is really fast, then sink, that means the channel will be always full. All right, and that is the role of a channel, so that the difference between the reading writing speed of sink and source can be balanced. Okay, why? Because most of the sinks, say for example disk, writing 1 gigabyte to the disk is faster in a single attempt. Writing one block size to a file system is really fast as compared to trying to write in 10 attempts the same data. Okay, because there is a every time there is a fixed cost of writing the data onto the disk. Therefore it's better to collect more data and then write to the disk, and that's what is the channel for. So this is the agent, Flume agent. So the way the architecture of Flume is that we we create agents on the network, and then we tell one agent that your your sink is on some other node. Okay, some other agent becomes the sink for one agent, And that way we can arrange all the Flume agents in a topology. Okay? So using this network of agents, we can flow the data from one location to another. Now let's try to set up a Flume agent and try to demonstrate the purpose of Flume. Okay? So pay attention here. So as we said, there are three parts. One is source, second is sink, and third is your channel. So we have to define all three. So first, we have told that there is agent name A1, and agent sources are only single because there could be multiple sources. Also note that here there could be multiple sources and multiple sinks. Okay? So sources for A1 is R1, sources sink is S1, and channel is C1. All right. Now next is that we are telling that we are telling that R1 dot type is netcat. We are telling that this is our source R1. Okay, it's netcat, meaning it has to connect to this particular port and generate the data and gather the data from that port. Okay, it has to connect to 4444 and write the data there, read the data from there, because okay, so which means we will have to run a service on this port from which Flume will be consuming the data. Okay, so this agent will consume the data from localhost and it will connect to this particular port and then consume. Next is the sink. Sink, here we have told that our type of sink is HDFS and location is this, meaning it will, whatever it reads from this source, it will write to this HDFS file. Alright. Next is the channel. We are telling that channel type to be in memory. Okay. Sometimes we can also, there are multiple kinds of channels you which can be used, such as disk supported and others. Okay. And we are also telling that what is the capacity of channel. Okay. So if the capacity of channel has exhausted, it will stop reading from the source. It will keep it blocked. Alright. Next is we are telling we are telling that we are connecting them together. We are telling R1 that your channel name is C. We are telling the sink that your channel name is C1. Okay. Basically, we connected the sink to channel and source to channel, both of them. And now you can visualize this. We have done basically this. We first told the agent that this is your source, this is your channel, this is your sink. And then we told the source that this is your channel, and we told the sink that this is your channel. Okay? So that is how you configure it. Alright? You can also download it. You can also download it from this location. And I have kept it in Asgiri Flume. So I can go to asgiri/flume, and here I have already created the config file. Alright. Now let's try to, so this is my Flume properties. This is little different, just the name of this one is little different here. Okay. And this is the folder where the data will be created. Let's open this folder in our Alright, so there is a minor difference in what I have just told. This portion, basically what it does is it starts a process at this particular port and start waiting for your data. The source starts waiting for the data on this port. Okay? Yeah. Is my voice audible to others also, or is it only Nitika? Hello? For Sanjay, it's fine. Okay. Okay. So basically, it creates a service on this port called 4444 and will wait for the data to receive on this port. Okay. Now let's run our Flume agent. Okay. Let's run our Flume agent, and this is our Flume agent running. So it says that the specified configuration file does not exist. Okay. Why? Because we are sending in this folder. Yeah. Now it's running, and let's open the HDFS folder. It is Hadoop 1 8000. All right. So Anitika, try reconnecting. All right. So now it has started on this particular channel. Okay. Now from anywhere, whether from my local machine, so this is my local machine, I can say telnet hadoop 1.nobigdata.com. I hope it works, but it has bound to that particular port. Okay, it's saying connection refused because I have not bound it to Hadoop 1. I've only bound it to local. Okay. So basically, Nitika, we haven't moved much. All we have tried to do is execute this command and started the Flume agent. Flume agent is running now. It's waiting for our input. Okay. And in the parallel, we are trying to generate the data. To generate the data, we will connect to the agent which is running on localhost at this port. Now it's waiting. Now we can write our data here. In the meantime, I will open the HDFS, and where did we store the data? Where did we mention that that is our, so we were writing it to somewhere. I think it's the same folder what I have mentioned here. So we are writing in Asgiri Flume web data in the HDFS. Okay, Asgiri Flume data, web data. Yeah, you can see that. Okay. So right now it has not created any new data. All right. These are the only file. Let me also delete them, move to trash, and refresh it. Okay. Now there is nothing here. All right. Now let's start writing the data. So we are running already the agent, and all right. Okay. So here is our source running. What does the source do? Source has started listening. It has started a service that is waiting for some data on 44,444 port, okay, and is waiting for our input. Now, here what we have done, now we have connected to the agent and we are giving some data to the agent. Okay. Okay, we are basically continuously giving the data. This is this is some data and this should be pushed into our HDFS continuously. Okay. Do you see the new data now? So here it has started creating the data for us. It's a binary file and the data type is long writable. Data type is byte writable and therefore you will require Java code to read this data. Okay. Although we can configure our sync such that instead of writing the data in the byte writable, it can also write in plain text. Alright. Since we are dealing with binary data, your data could be in any format. Okay, it makes it more portable to use it in, say, other formats. All right. So this way, the data is being pushed from our machine to this machine. Now you see, this is some data. Okay, this is some data. So that way, it's basically working well. All right. Is that clear to everyone? All we did was we started our Flume, which started a sync, which started a source, which is listening at this port, and then it is pushing the data to sync at this location. Okay? Nitika, is that clear? Great, great. So that was Flume, and this is how you can use Flume. This was just one example. You can form really, really complex systems using Flume. Okay, moving on. Right now, we have Uzi, but I'm going to skip Uzi for now. We will cover Uzi later. Let's move to Mahat for time being. Okay. So, yeah. All right. Okay, so we will just introduce what is Mahat, and then we can the hands-on example we'll do it later. Okay, so Mahat was a scalable library built on Hadoop, and now and they became the top level project in April 2010. And Mahat, the word means the keeper or the driver of the elephant. It's a Hindi word, and it was based on the paper called MapReduce for Machine Learning on Multicore. Okay. All right. So, yeah. What is machine learning? Machine learning essentially is programming computers to optimize a performance using example data or past experience. Okay. Instead of you writing exactly what needs to be done, you try to train the computer with an input data and an output data. Okay. With a training set, meaning input and output relation. Okay. So a best example so far I have found is this video, and this should really, you will definitely like it. So Mario machine learning, although it's little older, 2013, but this should give you a really good sense of what's going on. Okay, so in this video, what this person has done, he has basically written. So yeah, okay, I'm muting him. Yeah. So what he has tried to do is he has tried to let the computer learn to play by itself. So he wrote the emulator which basically tries to play on your behalf. And it did not teach anything at all about the game. All it taught, all it taught, all it trained the computer was to know that where is the score and how to press the keys. That's all it told the program, that this is this is where the score is, and these are the keys you can press. Okay, and and also a way to observe what is there in the game area. There is the red color, all of this is in the memory. So it basically built this program which behaves exactly like human while playing this game. So here it has, he is playing this. Okay, now at this point at this point this his program is stupidly playing the game and dies of old age. Now again he's jumping randomly, but moving automatically is figuring out that what to do. Okay, it's jumping randomly right now and does not do anything, and after some time it dies of old age. Okay, and next time, after few improvement by itself, it has started playing in few weeks like this. It is learning everything by itself. You can see that it's learning everything by itself. Now again it has got stuck here. So this is the program playing Mario and learning by itself. Nobody has programmed this program to do all of this. Okay, all that person has done is made sure that made sure that it knows where to see the score, and it knows how to see the how to read the memory in which this whole game is running. Okay, what happens in the when computer gets smarter than the designer? Sanjay, you will see that in a minute, and that's what will surprise you. And after a while it has started to play things really well, and so it does get stuck at places like here. It got stuck for quite a while and then dies of old age here. Okay, dies of old age. He keeps on trying more and more, but it dies of old age here. And after that, it has next time in the next way, it is starts to figure out it starts to figure out how to get out of that. And it keeps on going, and finally it has started learning really well. Okay, it has started learning really well. Now this is something very interesting, you will be surprised. See, and for some reason it dies because it figures out that it could have scored better. So in the second game, in, because it has got multiple life. Okay, and now this is something interesting. So it has killed the Goomba, even though Goomba was supposed to kill. So it figured out that the moment Goomba is coming closer, it starts moving the other direction and then hit it. So it found the bug in Mario by itself without any programmer. Okay, it found the bug in the Mario. Okay, and the most important part in the game was this realization, which you will get surprised at. Okay, so after a while, the program realized that there is no other way. There's no other way than there's no other way to win and avoid the loss. So it paused the game. So this program started pausing the game. As soon as when it has no hope left, it will pause the game. And that was interesting part of the machine learning, that it actually, these mathematical numbers actually started behaving like a real person. And if you remember in childhood, our my brother used to, throw my carom board when he starts losing it, because at a point he has no hope that he will win against me. Okay, and I also used to do that. So basically, after a point of time, the machine learning is really good. And things like finding bugs in Mario is something not people are able to do. Okay, finding this bug, that even though Goomba is coming to attack you, it found that bug and exploited it and figured out ways, is just marvelous, which essentially tells us that machine learning is far better for lots of tasks. Okay, all right, so this is how we conclude today's session, and I hope you enjoy this. So do watch this video, and in whatever he talks about. All right, he tried the same algorithm on multiple games. It played decently well. Okay, so this is like, you don't have to code everything. You just told the program that this is where you have to look up the score, this is where the memory is, and then you can keep on, you train. You basically, it automatically learns. Okay, so this is essentially machine learning. All right. Okay, then let's meet on next Saturday and carry on from here. On the next Saturday, probably we'll be discussing a very important concept, component called Apache Spark, and we'll also go quickly over machine learning, and then we'll also go quickly over Uzi, and and then we'll quickly compare the multiple databases. And okay, so no, not really. It will take more time actually. Okay. Next Saturday and Sunday it should be. Let me see what is up. So right now we on session 9. There is 10 and there is 11. Okay. All right. So that's pretty much for today. We'll see you on. Uh, okay. See you on next Saturday. So no, I think it will go on till Sunday. All right. Bye bye. Have a great week ahead, and also try out whatever we have done today. Okay, try out everything what we have done today, and that will give you a good confidence. All right, thank you. Bye bye everyone.